Ladies and gentlemen, please welcome to the stage from Transition Composites, Ray Blotteaux.
It started with a whisper, and that was when I kissed her, and then she made my lips hurt. I could hear the chit-chat.
Good afternoon, everybody. Hope everybody's having a good day. It's been pretty inspiring the last couple days looking at the state of the new technology and just how fast everything's changing. I'm the president of Transition Composites Engineering. We're based in Ferndale, Washington. And we're a product development and manufacturing company specializing in composite materials. Everything we do is for clients. We don't have any of our own products. So we basically work with people's sketches and 3D models and develop products for our clients. Most of what we do in this industry is proprietary, so we can't talk about any of the brands or any of the things that we're working on for most of our clients, but we get a chance to talk about some of the projects and some of the processes that we're involved with today. We work with the 90-10 rule, as we like to call it. I started out in the aerospace industry, and most of what we're trying to do is deliver 90% of the performance at about 10% of the time and the cost. I guess I'm an old guy in a young industry, which is kind of cool in some ways, except the old part. So I took one class as an aerospace engineering undergraduate student in 1985 in composites. Absolutely hated it. About 6 months later, I was commissioned in the Air Force and was working on F-16s and got a chance to meet my mentor, who said, "Sit down, kid, have a listen. This is where the world's going. If you pay attention, this can be the rest of your life." I ended up going back and getting a master's degree from Dr. Widoff after I got out of the military. So like I said, this is a young industry and there's lots of trade secrets. This is not like aluminum or steel or concrete that's been around for hundreds, sometimes thousands of years. This is all very new. Every project is a development. It's a little bit of an invention sometimes. A lot like a jigsaw puzzle. As we'll go through the list here, there's a whole bunch of different processes and technologies that are involved in making the parts that people are used to looking at. It's where we live. We enjoy it. We're 7,500 square feet of production space, 8 employees, veteran-owned small business. We've been around since 2007, been in the industry for a long time. It's nice when we've got time off to be able to be in the mountains one day and out on the water on the boat the next. So a little bit about composites for people that maybe don't know what they are. Carbon fiber, Kevlar, fiberglass are things that are commonly seen. Started out in 787, F-16 aircraft. It's come downstream into bicycle wheels and baseball bats. So we've got long, stiff fibers that you can see in the left-hand slide. So the blue fibers are very strong and very stiff. The loads are transferred through the fibers through a matrix or through a resin system. And because the fibers are only strong in the direction of their length, we stack these materials up to be able to tailor the engineered properties. A shot of our shop space. We've been in, it's basically an empty shell that we moved in a couple months ago, so it's been lots of work and not much sleep. So this is kind of what we're working on at the moment. We've got about 30% of our business is sports and rec. We do baseball bats, lacrosse shafts, bicycle rims, bike components, balance board decks, rifle stocks. Do some unmanned aircraft parts and prosthetics and orthotics, which we're going to go through kind of as a worked example. So these are all really different products, and we don't focus much on the product. We are process people. So most of the time our clients know what they want. It's our goal to be able to deliver what they've sketched out. So a couple of random shots of some of the things that we're working on at the moment. In addition to the products, most of what we do are the things that people don't see. So we design the factories and the equipment and the tools and the machinery a lot of times that's required to be able to make these components. Lots and lots of time spent on the computer. Everything starts sometimes with a 3D model, sometimes literally a pencil sketch. Lots of analytics involved to be able to get to the point where we're confident enough where we can cut a tool and go in and build parts. When we get down to the parts production end of things, Lots of chemistry and electronics and thermodynamics. These are liquid materials or that a lot of times are changing a phase. So they're going from something that's liquid to something that's solid under heat and pressure. We've got PLC-controlled machines that we use. So once we've got a process locked in, it's consistent and accurate. 90% of our business comes from our raw material suppliers, which is cool. So we get a chance to work with a lot of things that are new and next. Most of our clients initially show up looking for, they want finished product. The raw material suppliers, they basically, they're providing the input to be able to make the parts. It's our job to be able to put all the pieces together and actually, bring the product to life. So we're kind of the intersection of theory and reality. We start with the materials on one end, the design on the other, and we got to put all the pieces together. So currently we do a whole bunch of different types of softwares. We're really interested in working with Autodesk and Fusion and looking at where the world's going because it's kind of convoluted and complicated sometimes. We bring in materials, or we bring in CAD files from probably 8 or 10 different systems. We work with a geometry-based software called Key Creator. It's a real good translator. It allows us to be able to bring in things from CATIA, SolidWorks, Rhino, all kinds of different packages. We take those materials and we do all of our raw material development. So we have to take three-dimensional model, flatten it out into two-dimensional materials, and then build the two-dimensional materials back into 3D models or 3D parts. Yeah, there's a lot of time and energy and effort that goes into the front end before we can get to the point where we're actually cutting tools. We spend a lot of time doing finite element analysis. Currently, we're using Nastran. We're machining everything in Mastercam. Done a little bit of work with Fusion for machining. And then we do a lot of analytics. We do a lot of MATLAB work to be able to triangulate. And a lot of times when we're doing testing, we're going to go back and look at the FEA models and the test results. And a lot of times things don't line up the way we want them to, and it's a matter of going through and figuring out what's wrong and how to fix it. So here's an example on a project that we're working on currently. This is give you some of the ideas on what some of the shapes might look like when they're coming in. And basically, we've gone in and we've taken this part, and this is how we go through, do a tool design portion of things. So a lot of lofted, kind of convoluted shapes that we end up working with. Michael Sagan will appreciate some of the unusual things that we've worked on in the past. So software is a big next step for us. Just looking at how things are changing and how rapidly things are growing in the software industry. It's been really great for us to come out and see this, and it's definitely going to allow us to be able to spend some more time and focus on being able to take one model from the very beginning of the CAD life all the way through the finished product. Don't need to spend too much time on FEA. So couple worked examples. This is camera housing for an unmanned aircraft for a client that's down in Australia. We had an electronic file show up. We did the design work, the FEA work, cut a tool, and the part was actually in flight testing within about four weeks on the other side of the world. Carbon fiber bicycle rim. This is just going into production this month. It's a 14-piece tool that's made out of P20 steel. This tool grows from room temperature to 350 degrees, about 1.5 millimeters. We've got to hold about plus or minus 0.05 millimeter tolerance. So if you get the math wrong, it's an expensive mistake. And luckily, everything worked out. We're right in the middle of tolerance. And that's what the finished parts look like. That's one of the first parts coming out of the mold. This is a process that we're in the middle of licensing to a big baseball bat manufacturer that's interested in bringing manufacturing back to the US. So we've kind of fundamentally changed the approach. This is more of an additive manufacturing process where we're working with 3D robotically braided textiles. And then we're doing a liquid RTM and bladder molding process. Basically, we've met all our goals. This is going into mass production. We'll have finished parts screwed to the floor in the factory next month. Lacrosse shafts, similar process. So if you can see on the left-hand side, Basically, we're injecting the liquid resin into the parts. At this point, the carbon fiber is dry. The resin moves from left to right in the lower right-hand corner. Once the resin exits the right side of the tool, then we use high-pressure air to be able to consolidate the parts. And we do a lot of work with resin chemistry, so how we apply the pressure, when we apply the pressure, takes a lot of experience with resin. So we're good at keeping people close to us that are good at things that we aren't. Resin chemistry is certainly not our expertise, but we've gotten pretty good at it over the years by partnering up with some guys that know what they're doing. So right now, this is still a very manual process. This is a helmet that's being designed. Unfortunately, we're not like Boeing where we can have an automated tape laying system for every single part that we build. So we've got very skilled operators that build a lot of the parts that you're going to look at here in the next few minutes. And a lot of it's very patient and meticulous. This is a downhill ski helmet that we did for a client a couple months ago. This is a balance board deck for a company that's based in Southern California that we're just going through and going to be starting production for them next month. We've gone through and basically started doing a bunch of prototypes. This is something where, to be cost effective, we had to come up with ways to be able to make these parts in a different manner. This again is resin transfer molded, so this is kind of like a ski or a snowboard. That's what one of the first parts coming out of the mold looks like. And we did a bunch of development work to be able to integrate graphics into the part. So touch labor in the US is very expensive. We don't have the ability to be able to go through and sand and paint and apply graphics to everything. So we're working with some textiles companies down in Southern California right now. So the part on the right basically comes out of the mold and it's complete. We literally just deflash it, put it in the box, and it's done. So I want to walk through an example on something that we've developed here recently. This is a dynamic spring system for wounded warriors and for children that have typically drop foot. So if you've got damage to your Achilles, this is an orthotic device that helps. So this is how we started. This was the client's input. These are great guys. They're located just down to the south of us. This is what one of the finished CAD renderings look like on the assembly of the system. We're the guys in the back that are doing all the design and the math. They're the clinical people that are out in the field, and it's a real nice combination. These are the kinds of projects we like to work on. So this is all the front end, just some of the initial CAD work to be able to get to the point where we've designed the first parts. And first plaque of the compression molded carbon fiber. First finished part. It's the bracing system, and we've got a couple. So marketing and graphics, I don't have to pay for any of this. This is our clients. They've done a pretty nice job. So this is the carbon fiber spring, the assembly system. It's modular. They've got different springs that or different stiffnesses of springs, and then we've got shims that allow them to be able to change the cant of the spring. So if you can be a 90-year-old, 90-pound female, or you can be a 300-pound military guy with a big backpack, and same basic system setup. The calf and the footbed are cast by the orthotist in the field. So these are a lot of the line laser scanning and digitization that you see. Those are fairly commonly used techniques. And we got just a short clip of a young gentleman that's got cerebral palsy, and that shows the so you can notice he's got a little bit of an abnormal gait, and his feet don't point quite straight. And that's a bilateral system on him, and it allows him to be able to run around and go out and play like the rest of the kids on the block. This part right now is in Australia at one of the most advanced gate labs. They're going to have 10,000 frame per second high-speed footage shot here actually this week. So this is just launched and gone into production here. So where we're moving in the future is looking at more three-dimensional textiles technologies and basically starting with three-dimensional materials and moving to more of an additive type of a process. We've got a couple textiles manufacturers on the East Coast that we're doing some development work with. We've got a couple different applications in both aerospace and sports and rec that we're looking at, as well as an orthotics application. So what you see on these pictures on the bottom, these are materials that are woven by a robot and into a three-dimensional shape. So instead of taking a bunch of things that look like, cardboard box and trying to make complicated three-dimensional shapes, we've got something that basically looks like a wing spar when it goes into the tool. Thank everybody for their time.